Hello class, this is lesson 3-6 in your textbook, all about rational numbers. So hopefully you remember what a rational number is. It's different than a whole number or an integer. It is any number that can be written as a fraction. Okay, and the fraction, we'll just call it n over d, where n we know is the numerator and d is the denominator. And both of those numbers are integers, like 1, 2, 3, 4, 5, or -1, -2, -3, it's any of those. But also d cannot equal 0, so the denominator can never equal 0. So a couple things before we get into this, I just want you to remember that 0 over any number, as long as it still is not 0, equals 0. Or any number divided by any number again, the denominator cannot be 0, equals 1. Or another tip is -7 over 8 is the same as 7 over -8, which is the same as -7/8. Okay, so those are all the same. Don't get confused. So let's go ahead and simplify some fractions. So 9 over 55. If I don't know what they have in common, I'm going to list the factors. So for instance, I can multiply 1 times 9 to give me 9, or also 3 times 3. Or for the bottom number, 55, I can do 1 times 55, or 5 times 11. This is what I mean by listing the factors. And then I want to see what they have in common. And since they only have the number 1 in common, that means that it's already simplified. There's nothing greater than the number 1 that I could divide the numerator and the denominator by. So let's go ahead and try another one. This time let's do -24 over 32. And again, let's try to list the factors. So 1 times 24, 2 times 12, 3 times 8, 4 times 6, and I think that's about it. How about the bottom? 1 times 32, 2 times 16, 4 times 8. I think that's about it. So looking at what's in common, they both have an 8 in common, so I can divide them both by 8. And that's how I'm going to simplify this fraction. And I end up with -3/4 as my final answer. Okay, so if you're already pretty quick at finding what's in common, then you don't have to list the factors. For instance, I could divide top and bottom by 16. And I'm going to end up with 1/5. So see how fast that is if you can already be thinking of the factors. Let's do one more. -18 over 29. And I'm thinking that 29 is a prime number. So I really can't think of anything that would go into both other than the number 1. So this is already simplified as well. So why don't we go ahead and move on now. Some decimals can be rational numbers, which means some decimals can be written as a fraction. And there's 2 types of decimals. The first is called a terminating decimal. This means that it ends, it stops, it terminates, okay? So for example, 0.752, it stops, it doesn't keep on going. The second kind is called a repeating decimal. And a repeating decimal can also be turned into a fraction. So for example, 0.66666, and it just keeps on going, that I can turn into a fraction. There's other decimals, though, that don't fall into those 2 categories. And if they do not terminate, and if they do not repeat, then it is called an irrational number. Okay? So again, it does not end, there's no repeat. So for instance, a decimal that looks like this, how about 0.521179624289971. I mean, there's no pattern and it doesn't end. Or for instance, pi. You guys know pi. 3.141. It just continues to go on without any pattern. So looking at a terminating decimal now, what I want us to practice is to take that decimal and to turn it into a fraction to prove that yes, it is a rational number. So to do this, I think that the easiest way is by saying this decimal out loud, but the formal way, like the way that you originally were taught how to read a decimal out loud. Okay, so let's go ahead and practice a couple. For instance, you would probably say negative 5.59. That's probably how you would just typically say it, but the formal way is negative 5 and 59 hundredths. So let me write that down. So this is what I'm thinking to myself, and I might say it out loud, to write negative 5 and then the fraction 59 over 100. That fraction can't be simplified because it's an odd and an even, so I'm going to go ahead and box that. Now let's go ahead and try another one. This is 0.5714. So if I was going to say this out loud formally, I would say 5,714 10,000ths, because that 4 ends in the 10,000ths place. So let's write it as a fraction. 5,714 over 10,000. And I can simplify this. I'm going to divide them both by 2, and I'm going to end up with 2,857 over 5,000 for my final answer. Okay, let's go ahead and do a couple more. Our next example is going to be 4.37. So again, the formal way is saying 4 and 37 hundredths. So I can write this as a big 4 and then the fraction 37 over 100. And that's it. It can't be simplified. Let's go ahead and try one more example. 0.622. So the formal way is 622 thousandths because the final 2 is in the thousandths place. So this is 622 over 1,000, and I can simplify this. I can divide them both by 2, and I end up with 311 over 500. And that's it. Let's move on now to repeating decimals. So again, a repeating decimal, you can turn it back into a fraction. And so the way that you do it that I find is the easiest is just like before. Say it out loud the formal way, but you are going to take that denominator and you're going to subtract it by 1, okay? So that is going to be the key to help us writing repeating decimals. So for instance, how about 0.5555? It just keeps on repeating, right? And typically you would see this as 0.5 with a bar over it. So looking at that, that is in the tenths place. So to start, I'm going to write it as 5 over 10. But remember, I'm going to cross it out and I'm going to subtract it by 1. So really it's 5/9. Okay? Let's do another one. 0.123, 123, 123, and it keeps on going. So the pattern is 1, 2, 3 with a bar over all 3 of those. That 3 is in the thousandths place. So in my head, I'm going to write 123 over 1,000, but I'm going to cross it out. I'm going to subtract it by 1, which leaves me with 999. So now I have a new fraction, and I can still simplify it. I can divide it by 3. Then that leaves me with 41 over 333. Okay? All right, so that's repeating decimals. So for our final task today, we are going to just practice writing fractions now as decimals. So we're kind of going back and forth to show you that fractions and decimals are the same thing most of the time. And what you want to do is you want to divide the numerator, that's the top number, by the denominator, which is the bottom number. So for instance, when you have the numerator on top and the denominator on the bottom, You're going to divide by putting the numerator inside and the denominator outside. So let's go ahead and practice this a couple times and then we'll be done. So for instance, if I have 5/4, I'm going to put that 4 on the outside and the 5 on the inside, and then I can divide. 4 goes in there once. I'm going to add a decimal point and a 0 and drop it down. Now it's 10. 4 goes into 10 twice, which leaves me with 2. I'm going to drop down another 0. 4 goes into 25 times, and that ends it. So 5/4 is really 1.25. So for our final example, why don't we go ahead and convert the fraction -1/6 into a decimal. So we're going to start by putting the 6 on the outside and the 1 on the inside. 6 cannot fit into 1, so I'm going to put a 0 up there, add a decimal point and a 0. It goes into 10 once. I'm left with a 4, and I drop down a 0. And it goes in there 6 times, which is 36, and I'm still left with a 4. I'm going to drop down another 0. Goes in there another 6 times. I'm left with 4. Do you guys notice a pattern? I'm going to drop down another 0. That's 40. Goes in there 6 times again. So can you tell that it's going to be repeating? So my final answer is going to be -0.16 with a bar only over the 6. And that's my final answer. So hopefully this lesson was review for you, but if not, I hope that you feel more confident now with your fractions and decimals. I will see you guys in class.